Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem solving skill. First, we will analyze the problem on hand to find the related concepts. Then using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in physics. In this video tutorial, we will discuss a problem on the oscillations of a spring block system on a rough horizontal surface. The question is as follows. A block of mass 2 kg is connected to one end of a spring of force constant 40 newtons per meter as shown in the figure. The other end of the spring is fixed to a rigid vertical wall. The block is placed on a rough horizontal surface. The coefficient of friction between the block and the surface is 0.08. Initially, the spring is relaxed. Now the block is displaced by 44 centimeters and released. Find the number of times the block will pass its mean position before stopping. Before proceeding to solve the problem, let us recall the related concepts. For a spring block system executing simple harmonic motion on a smooth horizontal surface, the total energy of the system remains constant. For a simple harmonic oscillator, kinetic energy is zero at the extreme positions. Therefore, total energy is equal to potential energy, which implies potential energy at A is equal to potential energy at B. Therefore, amplitude of oscillations remains constant, which implies OA is equal to OB. When the surface is rough, work is done against friction. Due to this, total energy of the system decreases continuously, which implies amplitude of oscillation gradually decreases. Let the initial amplitude is equal to x0 on the right. When released, the block passes the mean position O and reaches the extreme position on the left where the amplitude is equal to x1, which is less than x0. Similarly, after the second pass, the amplitude on the right is equal to x2, which is less than x1. Let the block stop at the extreme position after the nth pass where the amplitude is equal to xn. For the first pass, distance covered is equal to x0 plus x1. Force of friction is equal to mu mg. Therefore, work done against friction is equal to mu mg into x0 plus x1. Also, decrease in potential energy is equal to half k x0 square minus half k x1 square. Therefore, we write half k into x0 square minus x1 square is equal to mu mg into x0 plus x1. This implies x0 minus x1 is equal to 2 mu mg by k. Similarly, for the second pass, we write x1 minus x2 is equal to 2 mu mg by k. And finally, for the nth pass, we write xn minus 1 minus xn is equal to 2 mu mg by k. Adding the equations, we get x0 minus xn is equal to n into 2 mu mg by k. The block stops after the nth pass if kxn is less than or equal to mu mg. Therefore, in the limiting case, we write kxn is equal to mu mg or xn is equal to mu mg by k. Therefore, equation 4 implies x0 minus mu mg by k is equal to n into 2 mu mg by k. This gives n is equal to x0 minus mu mg by k divided by 2 mu mg by k. Now, we are in a position to solve the problem in the question using these concepts. It is given in the question that x0 is equal to 44 centimeters, which is equal to 0.44 meters. Mu is equal to 0.08, m is equal to 2 kg, k is equal to 40 newtons per meter. Putting these values, we calculate the value of mu mg by k, which is equal to 0.04. Therefore, n is equal to 0.44 minus 0.04 divided by 2 into 0.04, which is equal to 5. Therefore, the block stops after passing the mean position 5 times, which is the answer to the question.